Yeah, here once again, good morning all. All of you, good morning.
Good morning, sir.
Good morning, sir.
Good morning, sir.
Yeah, okay. In continuation of last class, as we discussed about normal forms, today we are going to complete remaining normal forms so that we can finish the third unit. Now, before jumping into the today's topic, we will discuss about exactly first normal form, second normal form, third normal form, and BCNF and multi-valued functional dependency. So any one of you tell what is first normal form? Quickly. What is first normal form? Hello? What is the first normal form? Yeah, Mohan Sawan is mentioned. It contains only atomic values, right? Now, what is second normal form? What is second normal form? What is second normal form? Hello? Quickly, don't waste the time. What is a second normal form? Hello? Again, Mohan only texted the message. Many people, what are you sleeping? A relation R supports only full functional dependency, not trivial or partial. Yeah, it will be support only full functional dependency. It is not right, not a trivial partial. Yeah, it is non-trivial or partial. Right, right. Mohan, right. Your answer is right. It always supports only full functional dependency. You know what is full functional dependency, what is partial functional dependency. Now, what is third normal form? Any one of you please tell me what is third normal form? Hello. What is third normal form? I want to answer from other than Mohan, please. Ashita, 519. What is third normal form? Saurabh, no transitivity exists. Exactly. Here, instead of texting, please try to, Mohan even also uh, texted. Instead of texting, please try to unmute your mic. That will be good, maybe. Okay, it is going to avoid the transitive dependency. Clearly, the third normal form avoids the transitive dependency. Now, coming to the fourth normal form, BCNF. Before that, BCNF. What is BCNF? Any one of you? What is BCNF? Yeah, yeah, bias. I'm not asking full form of BCNF, Mr. Mohan. What is BCNF? Bias normal form. What will tell? Quickly. Already 10 minutes is done. Over. What is BCNF? Yeah. Mohan is texted again. Yeah, BCNF also a third normal form. It is an extension of third normal form. BCNF is extension of third normal form. Means here like third normal form, BCNF also avoids the transitive dependency. But in a third normal form, if you write x determines to y, y determines to z, then it is a transitive dependency. So that we are going to decompose x determines to y and y determines to z. Xy is separate table, yz is separate table. Yeah, that is same in BCNF as well as third normal form. Both are same. Means we have to avoid the transitive dependency. In the third normal form also we have to avoid the transitive dependency. In BCNF also we are going to avoid the or we are going to remove that transitive dependency. But the difference is in a third normal form after decomposition that x, y and yz. This xy means x determines to y. X is a candidate key. Y z, that is y determines to z. That y is a candidate key after decomposition. So this is the meaning in the third normal form. Coming to the BCNF, same rule x, y, y, z two separate tables, but x is a super key. Here y is a super key. This is the meaning. This is the difference from third normal form to BCNF. All of you clear? All of you clear?
Yes, sir.
Yeah, I repeated many times. Don't confuse. Right. Now, today we are going to learn about the fourth normal form. As I discussed in the last class, here what is fourth normal form? Because we discussed one topic. Okay, Mohan is asking, explain multi-valued functional dependency. 1 second. Okay, Mohan, I will explain. Tell me before explanation, what is fourth normal form? Any one of you? Any one of you, please. What is fourth normal form? Hello? Hello? Yogita Sri, can you tell what is fourth normal form?
Yes, sir.
Yeah. Tell me, what is fourth normal form? Anusha? Yeah, tell me, Yogita, tell me. What is fourth normal form?
There will be no non-trivial multi-value dependencies.
Yes, very good. Here we are going to avoid the multi-valued functional dependencies in relation, that is a fourth normal form. Fourth normal form always avoid the multi-valued functional dependency. So as Mohan is requested, explain the multi-valued functional dependency. Okay, I will go with multi-valued functional dependency, not a problem. Mohan, you want only the complete uh, how to identify multi-valued functional dependency, or you want complete things? Please tell me, Mohan. Okay, you want complete information about multi-value functional dependency. Okay, right. Okay, no problem. But please respond everyone quickly so that only I can complete fourth normal form and normal form today's session. Please. Because he asking again multi-value functional dependency. Please. Uh, response is required, please. If you won't respond, I cannot consider. Yeah. Sir, he is asking multi-valued dependency. Here, as I said, multi-valued dependency in the last class, again I will tell you. Here, when we are going to observe one, come to directly table, here vendor code, item code, project number. If you observe a relation, there is no any relation between one attribute to another attribute. Complete functional dependency is not available. Yes or no? because V1 I1 and V1 I2 is there. That's why there is no complete dependency. V1 again I1 is there because there is no functional dependency in this particular relation. Yes or no? Yes or no? You are asking again, I am explaining, I need a response.
Yes, sir.
Not in a text mode, please, because if text is not available here. Here, there is no complete functional dependence, right? Because here V1 is there, wherever V1 is there is a I1 everywhere, then that is a functional dependency, direct functional dependency. But here not like that, right? V1 I1, V1 I2, V1 I1 and V1 I2. That's why it is not depending. Your item code is not depending. Item code is not depending on vendor code. Yes or no?
Yes, sir.
Yes. Yeah. Even if you observe, the project number also not depending on vendor code because there is no functional dependencies available in this table. But if you observe very clearly, here some of the tuples are same. Some of the tuples are same. That is V1 I1. This is a tuple 1. In the same way, here V1, wherever V1 is there, I1 is there. This tuple is T2. These two tuples are same. Means some of the tuples in a relation may be the having functional dependency. And same if you take V1 again, here it is showing I2 and here also it is showing I2. Means the tuple T2 and tuple T4 are same. Means if you take same V1, sometimes it is going to provide or produce I1 and sometimes it is going to produce I2. Yes or no? Yes or no? So that is why we can write T1 equal T3, T2 equal T4. So that is why multi-valued dependency. Here these I1 and I2 are multiple values are based on V1. Yes or no?
Yes, sir.
Yes or yeah. Such type of functional dependency is called as multi-valued functional dependency. Means we can write vendor code, you can represent as a V, and you must write multi-valued dependency with help of the multiple arrow symbols, and item code we can represent with I. Here V multi-valued dependency to I. Here like that we need to identify such type of mechanism, such type of tuples are having multiple values dependency. You need to verify. Finally, you can understand that is a multi-valued functional dependency. Are you clear?
Yes, sir.
Here now, if you are one more example also you can take here. Here what happened? Here physics 101 course, physics 101, physics 101. But here this physics 101 and green is having only green. But same physics 101 sometimes brown also going to handle. Yeah, that's why if you take physics 101, sometime value is green, sometime values is brown. Means here also and some again the math is again 301, it is green. Here the things are happening here, multiple values are depending on physics 1. Means your course is multi-valued dependent on teacher. Yes or no? Understood?
Yes, sir. Yes, sir.
Multi-valued functional dependency is understood?
Yes, sir.
Yeah. Now, for this identification of multi-valued functional dependency, so generally here as per this example, we are evaluated functional dependency directly, that is F. But using this functional dependency, we can have closer set of functional dependency also, that is F plus. Here, as we told earlier, F is a functional dependency, F plus is a closer set of functional dependency. This closer set of functional dependency are evaluated from existing functional dependency on the table. So that here in this multi-valued functional dependency also we have the functional dependency as I showed just now. Are you clear? Are you clear?
Yes, sir.
Even based on this existing functional dependency, we can evaluate closer set of functional dependency, which is called as F plus, like normal functional dependency. We have the formulas here as per this theory, as per the things, we have the formulas based on the Armstrong axioms. First three rules are common. That is reflexivity. Here, that is, x reverse subset are equal to y. Then you can write x determines to y, and augmentation. X determines to y, xz determines to yz for any z. That is the augmentation, and a transitivity also these formulas are F. Already same formulas we can use for multi-valued functional dependency identification. Same Armstrong exact we can use. Clear? Clear?
Yes, sir. Clear, sir.
Now, if we wanted to extract the closer set of functional dependencies with help of this uh, Armstrong axioms for the multi-valued functional dependency, we have another 5 rules are there for extracting some more functional dependencies from the existing functional dependencies. That is F plus, that is a closer set of functional dependencies. The first one is MVD complementation, means if you are going to define a multi-valued functional dependency in your relation, that is x determines to y, then you can write x determines to r minus xy. The r is nothing but a original relation that contains x, y, z, etc. attributes. If you are identified x determines to y, then directly we can write x determines to r minus xy. Clear? Clear? Hello? Hello? All of you clear? I'm not
Yes,
getting
sir.
any.
Yes, sir.
Please. Now coming to the rule 5, that is a MVD augmentation. Generally augmentation rule is you can multiply one particular attribute from both the sides. That is the augmentation. In the same way, in a multi-valued functional dependency, also we have augmentation. That is, if x determines to y, and double, if it is there in your relation is there, w reverse subset are equal to z, then we can multiply w to the left hand side LHS and z to the RHS, because x determines to, when should we write x determines to y? Here when we have x reverse of subset of y only we can write, like how we have to write x determines to y. Same way, you are writing x determines to y because of x reverse subset of y, and also we have w reverse subset of z. So that w is multiplied with LHS, z is multiplied with RHS. Clear? All of you clear? Hello?
Yes, sir.
Yeah. Here coming to the transitivity. Generally in Armstrong axioms, transitivity rule is x determines to y, y determines to z, then we can write x determines to z. Correct? Yes or no? Quickly. Hello?
Yes, sir.
The same way here we can write x determines to y and y determines to z. Then we can write, generally we can write x determines to z, general rule. But here it is a multi-valued functional dependency. That's why x determines to this z minus y. So this is what MVD, multi-valued functional dependency transitivity rule. Clear? Clear? Hello? Yeah. Now, seventh one is the replication. Very simple rule. If you write x determines to y, directly you can write x determines to y. That is a multivalued function. There is nothing. Your x determines to y, if you are identified, directly you can tell the replication rule for multivalued functional dependency. That is x determines to y. Clear? Clear? Hello? Time is running quickly. Is this clear?
Yeah, yes.
The last rule is Colossians. They are very simple. If we are going to write x determines to y, and you need to verify, we need to verify, that is w intersection y. If you write, that must be the empty set. Means there is no common attribute in a w and y attributes, and w determines to z and y subset are equal to z, then only you can write x determines to z. Here, when you want to write x determines to z based on the x determines to y, here we need to check three conditions. The first condition is w intersection y must be empty, means there is no same attribute in w and y, and you must be defined w determines to z and y reverse subset are equal to z. So that only we can define x determines to z. This is a Colossians rule for the multi-valued functional dependency. Now clear? Mr. Mohan, all of it clear?
Yes, sir.
Yeah. Now shall we go with fourth normal form? Shall we go with fourth normal form?
Yes, sir.
Yes, sir.
Yeah. Now, as I said, fourth normal form is going to avoid the multi-valued functional dependency. Means when we are going to apply fourth normal form, we must check that relation must be in the first normal form, second normal form, third normal form, and BCNF. So that only we can apply the fourth normal form. This is very important. Already I told you. Then after verification of that relation must be in a BCNF, then we are going to apply the fourth normal form. If we want to apply the fourth normal form, we must find the multi-valued functional dependencies in that relation. If you found any multi-valued functional dependency in that relation, then you must be decompose the relation into multiple relations, so that the resultant relations must be in a fourth normal form. Clear? Is it clear? Because already you know multi-valued functional dependency. The definition is clear about fourth normal form? Hello? Quickly, time is running. The definition of fourth normal form is clear, all of you? Hello? I am not getting any voice. The definition of fourth normal form is clear. Quickly. The definition of fourth normal form is clear.
Yeah, yes, sir. Yeah.
Now, as we told just now, that given relation must be in a fourth normal form, BCNF, then only we go with the fourth normal form. Now, if you consider R be a relation schema and X and Y be a attributes of R, F means functional dependency be a set of dependencies that includes both FDs and MVDs, functional dependencies and multivalued functional dependencies. If the relation R should be in a fourth normal form, for every MVD X determines to Y that holds on R, one of the following statement is true. That is, Y subset R equal to X, XY equal to R, or X is a super key. So that we can find the multi-valued functional dependency. Here coming to this table, can anyone tell here what are the what is the is there any multi-valued functional dependency in this table? Hello? Anyone please tell me. Multi-valued functional dependency, tell me here. Is the screen is visible? Is the screen is visible?
Yes, sir.
If it is yes, tell me. If it is yes, tell me what is what. Please identify the multi-valued functional dependency here.
Yes, sir.
I am not asking yes.
And P2 are
Sorry?
P1 and P2.
Someone is telling, but your voice is not audible. Please, can you repeat
Tuple
once?
1 and tuple 2, sir.
Yeah. Now here, if you observe, here B is there and C1 is there. Now B is there, C2 is there. Again B is there and C2 is there. Means here B, sometimes it is giving C1, sometimes it is giving C2. Yes or no? Yes or no?
Yes, sir.
So that the multi-valued functional dependencies B determines to C. Yes, we are identified multi-valued functional dependency in this relation. So this is not in a fourth normal form. So that we must be decompose this relation into two relations, that is MVD. Okay. So that BC into one relation and BAD into another relation. So BC into one relation and BAD into another relation. Are you clear? So that we are avoided, right? Here, how many records we have written? 3. But here, after decomposition, only 2 is enough. Here and here. Means we are avoided more redundancy because of this decomposition of relation with help of fourth normal form. Are you clear? Because how to write, and for BC, for B and C, how to write B and C1, B and C2. Enough. Next, B, A, D. Then how to write B, A1, B1, B, A2, D2. Are you clear? Are you
Yes, sir.
clear? Yeah. Yeah. This is what exactly the fourth normal form. Now we'll go with some more example for the fourth normal form. Please, everyone, please immediately you must identify multi-value functional dependency. We need to finish the fifth normal form also in the today's class. Please, don't waste my time, please. Now, the fourth normal form, as per the book definition, a relation will be in fourth normal form if it is a Boyce-Codd normal form from as multi-valued dependency, as we just now we discussed about that. I don't want to go much theory. Now coming to this example. Now tell me, student ID, course, and hobby. Tell me what is the multi-valued functional dependency here? Is there any multi-valued functional dependency?
Tuple 1 and tuple 2 student ID is
Yeah.
21.
Yeah, because student ID sometimes telling computer course and student ID sometimes telling math. So that these two are going to have multi-valued dependency so that we can decompose relation student ID course to one relation and course to hobby to another relation. So student ID hobby and student ID course. So like this, we can decompose the relation. Now these relations are in a fourth normal form. Clear? Clear? Very simple. If you know multi-valued functional dependency, this is very simple. All of you clear?
Yes, sir.
Yeah. Now coming to
Again.
coming to one more example. Subject, lecturer, and books. Now tell me is there any multi-valued functional dependency here?
Yes, sir.
Tell me what?
Tuple 1 and 2
Mathematics to lecturer. Here mathematics Alex, mathematics Pastor. Means what happened? Here only one mathematics is going to refer to different lecturers. So that two different dependencies. So that we can define subject to lecturer in one table. How to write? Subject multivalued dependencies to lecturer. Yes or no? Yes or no? Hello? Hello?
Yes, sir.
Even here we can observe lecturer Alex math books 1 and Basco and math books 2. Here also what happened? Your books determines again lecturer, that is also a different, right? Same textbook. Alex is there for lecture and Basco is there. Again, there is a two things also we can use. Multi-valued functional dependency. Yes or no? Yes or no? Hello?
Yes, sir.
Even we can take another normal functional dependency. What is that? Here, mathematics books. Mathematics is book math book 1 and mathematics math book 2. Again, we have different multi-valid functional dependency. So that we need to write here, we need to decompose table into subject lecture and subject book. So that there is no chance of multi-valid functional dependency. Clear? Clear?
Yes, sir.
Yes, sir.
Yeah. Now coming to one more. Here I am giving more example for understanding. If you are having any doubts, please ask me. Now movie name, shooting location, listing. This is the movie table database. Now tell me, is there any multi-valued functional dependency here? Is there
Tuple
any?
1 and 2, tuple 3 and 4.
Sorry, can you repeat once?
So for tuple 1 and tuple 2, and again for tuple 3 and tuple 4.
Yeah, tuple 1 and tuple 2. That is movie 1 UK, movie 1 UK. Okay, same, not a problem. But when wherever the movie 1 will come, it will be acts same. Check this. The movie 2 Australia, movie 2 Australia. Now here movie 3 India. Now here it is a not a multi-valid functional dependency. It is a completely functional. It is what? It is a normal functional dependency, right? Yes or no? Is this multi-valid functional dependency or normal functional dependency? Hello? Hello?
Normal function.
Means M determines to yes, correct? M determines to yes, correct?
Yes, sir.
Yeah, as per the replication rule in a multi-valued functional dependency, how to write?
M determines differences.
Yeah. So there is a multi-valued functional dependency. That is F plus rule. That is what I told you. Now you can decompose movie name, shooting location into one relation and movie name listing into another relation. Movie name, shooting location and movie name listing into another relation. Clear? Clear? Hello?
Yes, sir.
Yes.
Right. Coming to another example, student ID course hobby. Now tell me, is there any functional dependency there? Any categories of functional dependency is there?
Multivalued.
Multivariate. What is that? SID 1 determines sometimes science, sometimes math. 2 CAS and sometimes PHP. So that SID multivalued dependence on course. Yes or no? Yes or no? Hello?
Yes.
Even if you observe SID and hobby, here also SID 1 is determined sometimes cricket, sometimes hockey. 2 also sometimes cricket, sometimes hockey. So that will also will come. Yes or no? The 2 actually 2. 1 is there also we can decompose. Even 2 also it is there. Whatever the way you can take it. Understand? Hello? Hello?
Yes, sir.
Yeah, so that we can decompose into two relations. One is SID course, another one is the SID hobby. Yes or no? Yes or no? Yeah, please respond quickly. Time is running. I have to finish the things. Why you people are not responding? Are you watching like movie? Is this clear?
Yes, sir.
Right. Here, one more example. This is already I told you. This is very important example. Wikipedia example. It is very famous example. Here, restaurant pizza delivery permutations. The database is a real-time example. Here, restaurant, pizza variety, and delivery area. Now check. Is there any functional dependency? Is there any functional dependency?
Yes, sir. Multivalued.
Multi-valued. That is, restaurant determines to pizza variety because A1 pizza thick crust, sometimes it is stuffed crust. Same A1 if you take. Here, elite also different. Okay. Here, Vincenzo is also some different. Means every time it is showing different dependencies. So that we can write a multi-valued functional dependency, that is R determines to P. Even though we can take it restaurant with delivery area also. Restaurant and delivery area also, we have different functional dependencies we got. So that here we can write two categories. Yes or no? Hello? Have you clear this?
Yes.
So we can decompose the relation into here. Restaurant pizza variety, restaurant delivery area. Clear? Clear. So that we can avoid the redundancy. Clear? Hello?
Yes, sir.
Yeah. Now all of you understood this fourth normal form.
Yes, sir.
Now coming to fifth normal form. Before entering into the fifth normal form, we need to discuss about joint dependencies because this fifth normal form also very easy actually. Very easy. Don't worry about this. Very easy. Your fifth normal form will tell it is going to avoid, it is going to provide a joint dependency, not avoiding. Here up to fourth normal form, always we are telling it is going to avoid. But in a fifth normal form, we must be include a joint dependencies in the relation. Clear? So don't confuse, don't tell, avoid. Here in this fifth normal form, except remaining whatever the things we discussed in the fifth normal form, it is going to accept the joint dependencies. Clear? All of you clear? If any joint dependency is not there, we need to give a joint dependency with help of fifth normal form. That is what the fifth normal form. Clear?
Yes, sir.
Hello? Yeah. Now that's why before entering into the fifth normal form, what is joint dependency? We will learn. Already you know the joint dependency, but even I am telling. You know, the joint dependency means after decomposition of your relation. For example, you are decomposed these two relation uh, BCAD into BC into one relation, BAD is one relation. Here, what is the joint dependency here? Tell me. What is the joint dependency in these two tables? Hello. What is the joint dependency in these two tables, BC and BAD?
B.
Huh? B. Here, this is a common attribute. Here, this is a joint dependency. Means, if joint dependency will tell after decomposition, all the tables must be have this joint dependency. If any joint dependency is not there, you need to add that column and you need to divide the table with all combination of joints. But here what happened? BC and BAD. These two tables, BC is there, BAD is there, but BA combination is not there, and AB combination also not there. So that's why we need to decompose all the relation into multiple relations with joint dependency. That is what exactly the fifth normal form will tell. Clear? Clear? Hello?
Yes, sir.
Yeah, that is the joint dependency. First of all, before entering fifth normal form, coming to the joint dependency is a further generalization of MVD, multi-valued functional dependencies. A joint dependency, JD, you can represent as a this joint symbol. R1 to Rn is said to be whole over a relation R. That is R1, you need to decompose R2, R3, R3 up to Rn. These many number of relations we can decompose from the R. It must be contains joint dependency. That is what lossless joint dependency of R. Okay, you need to decompose smaller relations, but you maintain a joint dependency so that we cannot get any data loss. That is what lossless joint dependency. Here, in the same way, the joint dependency we can write MVD x determines to y on a relation R can be expressed like this: joint dependency x comma y x of R minus y. So this is what exactly the fifth normal form must contains the joint dependency. Clear? All of you clear?
Yes, sir.
Yeah, the simple mechanism is here. Here the table is project number and item code, CT and CD. Now what happened? You must be take teacher and book, because from this above example we need to take. Where is the example? Yeah, we applied only fourth normal. What is the fourth normal form we applied? Course, teacher, book, we applied fourth normal form and we decomposed. Course teacher is one relation and course book is one relation. Yes or no? Yes or no? After fourth normal form, I am telling here.
Yes, sir.
Now here, what is the joint dependency here? Course is the joint dependent. But here, course teacher is there, course teacher is there, course book is there. But there is no relation between teacher and book, right? Yes or no? Here we are not provided any relationship between book and teacher directly. Yes or no?
Yes, sir.
So that fifth normal form will tell here after decomposition of fourth normal form based on the table, you need to take all the combination of attributes. Your course teacher is there, course book is there, then you take along with these two to take teacher book also. Here, teacher book. What are the combinations will come? Teacher, green, mechanics, vector, optics, and geometrics. So these four will come. Yes or no? And brown, mechanics, optics will come. Understand? All of you understand? This is the fifth normal form intention. Means we need to take all the combinations as a result. That is a fifth normal form. So that is what has taken teacher and book here. Green extra along with those two. Course teacher is there and course book is there already after fourth normal form. Fifth normal form is going to tell you need to add all the combination, that is teacher and book. There green, mechanics optics is there, brown mechanics optics, and green mechanics vector geometry. So all these combinations must be right. That is called fifth normal form. Understand? Very easy. There is no any specific mechanism. Here I will show you some more examples for this. Please, subject, lecturer, semester. Subject, lecturer, semester. Tell me here, as this is not in a fourth normal form, right? Is there any functional multivalued functional dependencies there here? Yes or no? Because fifth normal form is immediately applied after the fourth normal form. Here, that's why Here at the time of fourth normal form only we can apply the fifth normal form. That's why this is not in a fourth normal form. Tell me, is there any functional dependency?
Yes, sir. Multivalued. Computer. Math.
Yeah, subject computer sometimes defines Anshika and sometimes defines John. So that it is having multi-valid functional dependency. Yes or no? Yeah. So that we need to decompose the relation into two relations. First, subject and lecturer is one relation. Subject and semester is another relation. Clear? Clear? Subject and lecturer is one relation. Subject and semester is another relation as per the fourth normal form. Clear?
Yes, sir.
But as per the fifth normal form, what you need to add extra? As per
Lecturer
the
and
fifth,
semester.
lecturer and semester we need to add. Means we will get the 3 because we need to have all combinations which contain functional dependency. That's why semester subject, subject lecturer, and semester lecturer. Clear? Clear this? All of you clear this?
Yes.
Hello? All of you clear this?
Clear, sir.
Yeah. Here like that, some more example we'll discuss. Employee skills, employee job. Now here, multi-valid functional dependency is there or not? Multi-valid functional dependency is there or not? Java, sometimes employees David, same Java employees Emma. Yes or no? Hello?
Yes,
Hello?
sir.
So that we can apply fourth normal form along with the fifth normal form. Yes or no? Then what are the tables will come? Hello? I'm not getting your response quickly. Time is running. What are the relations are going to decompose after fifth normal form? Hello? Are you following? Are you following?
Yes, sir.
Then tell me what are the relations are going to decompose from this after fifth normal form?
Employee name and employee skills, employee name and employee job.
Only two? After fifth normal form, I'm telling.
And then employee skills and employee job.
Yeah, very good. So basically, employee name, employee skills, and employee name, employee job will come. Here after that, employee skills and employee job also will come. So this is what exactly the fifth normal form. So please tell me, this is one more example, subject, professor, and semester. Your data structure, Madhurima, sometimes Shravan. So in the same way, Automata, Abhijit, and Susmita. So like that, we have different multi-variable functional dependencies. Yes or no?
Yes, sir.
Yes. Yeah. Here for this we need to apply fourth normal form along with the fifth normal form. Now tell me, after decomposition, what are the tables will come?
Subject and professor, subject and semester, professor and semester.
Yeah. You know the same story is it. That's why I don't want to few more example. This last example, this is already I told you Wikipedia example. I'm discussing every time because in industry people you ask such type of things. Again, same traveling salesman production availability by brand. So this is a real-time example. The traveling salesman brand and product type. So if you observe here, Jack. Whenever Jack is there, the brand is ACME, and sometimes Mary, the same category of brand, but same brand is going to given by sometimes Louis also. and ACME also Lewis. So that's why there is no direct functional dependency. There is a which type of functional dependency it is? Which type of functional?
Multivalued.
Multivalued functional dependency. So that we need to apply fourth normal form along with the fifth normal form to avoid multivalued dependency here and to add more join operation dependency here. So that what is the outcome? What are the tables will get? Three tables will get. What are the tables? Tell me. Travel. Tell me. Hello.
Traveling salesman and product type. Traveling
Yeah.
salesman and brand and product type.
Yeah. So these are the three tables we can get as an output. So this is what exactly normal forms. All of you understood today's class? All of you understood
Yes,
today's
sir.
session? Yeah. Now all of you understood normal forms? All of you understood normal forms? Yes or no? Fifth normal form definition. The fifth normal form is going to accept joint dependency. Mohan, are you there? Fifth normal form always to apply the joint dependency for all combination of table, decomposed table by fourth normal form. Because fourth normal form is going to decompose the table based on the multivalued functional dependency, but we can have joint dependency only two tables from the existing table, but we need to book's definition only I am telling. Always the fifth normal form must be accept joint dependency for all the combination of tuples in a original relation. Clear? Clear? Yeah. Fifth normal form is going to apply joint dependency for all the combination of attributes from the original table, from the source table. So this is what exactly the definition of normal form. All of you clear? All of you clear?
Yes, sir.
Yes, sir.
Yeah. Now normalization is completed. Here I am telling all of you must apply all normal forms to your database. That is going to cover by your third experiment. Here by Saturday, all of you apply all normal forms and update your records so that we'll go for the next experiment on coming Saturday. Okay? While applying, if you are having any problem, if you are facing any problem, please text me or ask me so that I can give the clarification. Is it clear? All of you, is it clear?
Yes, sir.
Yeah, please do that and complete the task so that we will